So in this section we've been talking about scale and similar figures. Just as a review before we do that, again, similar figures have the exact same shape but generally different sizes. So like we're saying here the ABC, right? ABC is similar to XYZ. And remember that order matters, XYZ. That means the A, notice the A here and the X come first. That means A matches X. Notice they're both 64 degrees in my picture. B is in the middle and so is Y. That means B and Y match up. So those two angles are 61 and 61. And then C comes at the end, so C and Z match up both at 55 degrees. It also means that the sides are proportional. So this side AC, notice A and C, first and last, and they match X and Y. So, or X and Z, I'm sorry, X and Z, they match up. And again, they're proportional. They're not the exact same length, they are proportional. That means AB matches XY, and BC, notice BC, matches YZ. So there are two things, and if that wasn't clear enough, maybe add this to your notes. Similar figures, there are two requirements. Corresponding angles are equal, and corresponding sides are proportional. So these are the two requirements to be a similar figure. You might want to add that to your notes under similar figures. So in this first example here, we say parallelogram ABCD is similar, that's that little squiggle, to parallelogram EFGH. So ABCD, EFGH. That means that this side over here, AD, right, matches this side EH, as we've discussed, and this side AB matches this side EF. Now the great thing is when we're trying to solve these, they start out in a very similar fashion. We've seen this before. Now you might see your book set up slightly different than the way I'm going to. So I know that the X matches the 18. Because they are the sides that are proportional. The X matches the 18. Notice they write them up to down here, and I write them side to side. It's going to get the same answer. That also means the 16 matches the 24. Now notice here, so over here on my left side, this is my smaller one. And over here on my right side, this is the stuff from the bigger one. Again, it doesn't matter. If you take what I've written and look at the one that they've written and turn it sideways, it's going to look exactly the same. Alright, so cross products are going to also work out the same. So the X and the 24 get multiplied, so 24X equals, and 16 times 18, so 16 times 18. So it's going to give us 24X equals 288. Divide off our 24 on both sides, and X is still 12. Again, it might look a little different than the way they set it up, but this is another way to do it. Same thing. So pause here, go back to Class Kick, and work a problem. And this one comes from the previous example, so we know we already have 12 and 16 for our sides. So we have the 12 here and the 16 here. Again, that comes from that other example. So now we know if KL, we're going to say KL right here is 21. I want to find KN, so this is the one I'm looking for. Again, it's going to be a very similar setup here. So now the setup is pretty straightforward here. We're going to see, we know that the 21 matches the 16, and the X matches the 12. So again, starting out like this, the 21 matches the 16, the X matches the 12. Cross products, 21 times 12, that's 252, and X times 16 is 16X. Divide off that 16, and X is 15.75. It does say rounded to the nearest tenth, so that means that X rounded is going to be 15.8. And there we go. Let's continue for more examples. So here's one of my favorite types of problems. We get to use indirect measurement. Actually, I worked this one in your video, but we're going to do it anyway. Noticing here, I have a 5-foot tall person, right? So a tree casts a 10-foot long shadow. A 5-foot long person casts a 4-foot shadow. So tree of unknown height, so I'm going to go ahead and put an X there so we don't forget that. right, casts a 10-foot shadow, and a person of 5 foot casts a 4-foot shadow. And it really just makes two similar triangles. It's going to be up to you how you set this up. But, again, I like to start like this, right? And I know that the 5 foot matches the X. So 5 matches the X. So small to big, right? And I know that the 4 matches the 10. 4 matches the 10. Cross product fun. 5 times 10 is 50. 4 times X is 4X. Oops, it's not a very good 4. There we go, 4X. And when we divide off that 4, X is 12.5. Don't forget to label that as feet. So there we go. Go ahead and pause here, go back into class kick and work one. Okay, so let's go through and read this one. A building, 70 foot high, so a 70 foot tall building, casts a 150 foot shadow. A nearby flagpole casts a 60 foot shadow. Draw a diagram, use similar triangles to find the height of the flagpole. So let's draw a building here first. So we have a building right here. Don't forget the sun's up here, it's shining, it's a beautiful day, right? Building over here, and then we know that that building is 70 feet high. And that building casts a shadow of 150 feet. So there's the shadow, 150 feet. And you'll note here, this obviously creates a similar triangle, right? It's going to be similar to the one I'm about to draw. And we know that the flagpole, we don't know how tall that flagpole is, but it casts a shadow of 60 feet. So again, the height of the flag is what's unknown. And again, so we have two triangles here. So we know that the X is like the 70, right? So starting like this, X is like the 70, and the 60 is like the 150. And we know that 60 times 70 is 4,200. That equals 150x. Divide off our 150, just like we've been doing. And x is 28, and don't forget to label it, feet. And that's usually on most of these problems, that's one of the points is assigned to the label, so make sure you do label that correctly. Keep going for a third example. Alrighty, so on this one, we're finally going to use that scale idea, but it's going to look just like the ones we've been doing. Scale of a map is 1 inch is 44 miles. But how far is it from Sacramento to Santa Rosa? So you're going to measure on there in your map, and you can use the ruler and find out it's about 1.5 inches on the map, right, from Sacramento to Santa Rosa. So that means, again, we're going to start like this, right? And I like what they've done here, the map over actual, so inches over miles. So I put the scale over here first. So I know that 1 inch is 44 miles. And I know if I measured 1.5 inches, that's I don't know how many miles. Now another way you could have set it up, again, you're going to get the same results. You could say 1 inch equals 44 miles. And we would say 1.5 inches equals I don't know how many miles. And we're going to have the same with the same answer no matter what. So if you take a look at your cross products here, on this one you're going to get 1 times x is x. Here you're going to get 1 times x is x. Here you're going to get 44 times 1.5. Notice you're getting the same cross products either way. That's why this works out no matter which way I set it up. But again, you can't start mixing them all around. You can't say that 1 inch over here is I don't know how many miles, and you can't say that 1.5 inches is 44 miles. That doesn't work. You have to get the same cross product in either way you do it. So anyway, either we'll take this the top one here. So we get x, because it's 1 times x, right, equals, and then 44 times 1.5, which is 66. There's nothing to divide by because I multiplied by 1. So you need to make sure we label this as miles. So pause, go into class kick and work one. Okay, so for this example, again, starting like this, and you can, again, go either direction. But remember, 1 inch is 44 miles, right? So we know that 1 inch is 44 miles. Okay, so this would be inches over inches, right? So we know that the distance from San Jose to Sacramento is about 121 miles. So we want to know how far would that be on the map. I don't know why you want to reverse that, but whatever. So the miles have to go over the miles in this case, and x inches. So a little bit of cross product fun here. 1 times 121 is 121. X times 44 is 44x. Divide off that 44, and we find that x is 2.75. Don't forget to label it. In this case, it's inches because we're looking for the distance on the map itself.